circle theorem, we need to find out the idea of circles first. Now, assuming we have a point, say O, and we want to draw another point which is 5 centimeters away from O, let's say point P. Now, we are trying to draw other points which are also 5 centimeters away from P in many other directions, as many as we can. We keep drawing the points till they get closer and closer, all 5 centimeters away from the fixed point O. Now, what shape are we forming? We can find out that is what? A circle. So with this, we can define a circle as a set of points which are all equidistant from a fixed point, which is the center. And in case of this our circle, the fixed point is O and the equidistance is what? 5 centimeters. Now, we also need to see some parts of the circle that we may be needing during our circle theorem lessons. So starting with the circumference will be needed, so you have to take note of the circumference. Also the center, which we always refer to as point O, the fixed point. Also the diameter, say AB. Again the radius, say OC, OB or OA. Also we need a chord, say DE. Again we need an arc, also say arc, DE. Also we need a sector, yes, as you can see. Last but not least, we need the segment of the circle. So these are the parts that we may be using in our discussions. Now, starting with the circle theorems, assuming you have a circle with points A, P, Q, R, and B as points on the circle, and AB is the chord or the arc we want to use. Now, the angle made at P, made at Q, and made at R are angles subtended at the circumference by the chord AB. I hope this is much clearer using the diagram. Let's continue. Now with the theorem 1, what does the theorem itself says? The angle a chord subtends at the center of the circle is twice that which it subtends at the circumference. So the 3 diagrams here depicts 3 different cases in which theorem 1 can be what? Experienced or shown, as you were taught earlier in your SHS. Now mathematically we can represent the theorem 1 as y equals 2x, where y stands for the angle made at the center and x or 2x is twice the angle made at the what? Circumference. Now let's prove this theorem. So our task is to prove that angle POQ is equal to twice the angle PRQ from this diagram we have. We first have to make a construction, that is draw a line from R to O and extend it to N, as you can see. Again, let's take the proof, but before that we label the angles that have been created by our construction and it will aid us. For the proof, we first have to take note that line PO, line OR and line OQ are all equal because they are the radii of the circle. Also angle X1 and X2 are equal and y1 and y2 are equal since they all find themselves in an isosceles triangle. Now angle PON is equal to angle x1 plus x2, and it gives us the sum of 2x2 because x1 and x2 are equal. Also angle QON is equal to y1 plus y2, which sums to 2y2. Now our final angle, that is one we are to prove, POQ, is equal to angle PON plus QON, and this gives us 2x2 plus 2y2 when we substitute their values into the equation. Now we factorize the 2 out and we have x2 plus y2. Now from the diagram we can find out that x2 plus y2 gives us angle PRQ. So this is what was to be proven. Now with theorem 2, it says the angle diameter subtends at any point of the circumference is 90 degrees. So this diagram shows also 3 various cases in which it can occur. So mathematically we say x is equal to y and they are all equal to what? 90 degrees. Now let's prove the theorem 2 using this circle we have with the triangle in it, where AB is our diameter. We are to prove that angle AXB is equal to 90 degrees. Now the proof, we can say that angle AOB is equal to angle twice the angle AXB. That's from the first theorem. So we also know that AOB is 180 degrees since it's a straight line. That tells us that twice the angle AXB is equal to 180. So we can find angle AXB, which gives us a 90 degrees, which is what to be proven as theorem 2. As simple as that. I hope you are enjoying the proofs. Now let's move on to theorem 3, which will be ending today's lesson because we will have to continue the other theorems next week, hopefully. So the theorem 3 also says the angles a chord subtends at the circumference in the same segment of the circle are all equal. So we can see from the diagram x, y, and z are different angles and they are all subtended at the circumference, and we say they are equal. Mathematically x equals y or x equals y equals z. Now let's prove this. What do we need to prove? From this diagram we have to prove that angle made at Q equals that of R and is the same as that of S. To prove this we need to construct some lines. Now joining AB at the center will help us prove this. Now let's take the proof. With our construction we can find out that angle AOB will be equal to twice the angle X that is made at Q from the first theorem, and the same thing is true for the angle made at R, that is twice Y, also from the same first theorem, and that also happens to the third one, that is angle made at Z. So since all these angles are equal to each other, we can say that hence X is equal to Y as well as equal to Z. So we can finally conclude that the angle made at Q is equal to the angle made at R and also angle made at X. How simple this may look, but you need to do more practice to become more perfect in it. So this brings us to the end of today's lessons. Thank you for watching. Till we meet again.